welcome to another module in this massive open online course. So, previously we have seen frequency division multiplexing, in which several signals are multiplexed in the frequency domain, alright. So, in this module let us look at another technique of multiplexing, that is time division multiplexing. Okay. So, naturally in time division multiplexing, alright, the signals are multiplexed in the time domain. So, let us look at in this lecture, let us look at time division multiplexing, that is TDM. Okay. And as we know, time division multiplexing, as we know, alright. So, first let us look at, so TDM, first let us realize that TDM is an application of the sampling, right. TDM is an application of sampling. So, TDM employs sampling. So, TDM is an application TDM is an application of sampling, alright. And in time division multiplexing, as we already seen, similar to frequency division multiplexing, right, signals are being multiplexed. So, several signals are multiplexed in the time domain. So, it is a multiplexing scheme, which means several signals are multiplexed or basically combined. Several signals are multiplexed, correct. These are multiplexed to form a composite signal for transmission over the channel, multiplex in the time domain. To form a composite signal for transmission over a communication, for transmission over a channel or a communication channel. Okay. So, several signals are multiplexed. So, similar to frequency domain division multiplexing, several signals are multiplexed into a composite signal. In time division multiplexing, this multiplexing is done in the time domain, and this is achieved via sampling. Okay. And now, so TDM, so let us look at operation of TDM. Let us look at the operation of TDM. TDM operates as follows: each signal, so TDM operates as follows: each signal is first low pass filtered to remove undue. So, in the first step, each signal is low pass filtered to first remove the to remove the undesired frequencies. Okay. So, the signal is low pass filtered to remove the undesirable frequencies. The signals to be multiplexed are then applied to a commutator which alternately samples the different signals to be multiplexed. So, these signals, these different signals which are to be multiplexed are applied to a commutator. Okay. The commutator is a high speed switching device which alternately samples each of these signals to be multiplexed. Okay. So, these signals are subsequently applied to a commutator. Okay. This is a special device, commutator, which alternately samples the signals to be multiplexed. So, these are applied to a commutator which alternately samples the signals to be multiplexed. Okay. And this commutator is implemented, this commutator is implemented using high speed electronic switching circuitry. Using high speed is implemented using high speed electronic switching circuitry. So, if I look at a schematic of this diagram, the schematic looks as follows. So, I have M1T, that is the first signal, similar to your frequency division multiplexing. I have M1T, okay, which is the first signal to be multiplexed, M2T, so on up to MNT. These are the n signals to be multiplexed. Okay. So, we are saying M1T these are n signals to be multiplexed. We pass them through, each of these is passed through a low pass filter to remove the undesirable frequencies, correct. Each is passed through a low pass filter to remove undesirable frequencies, okay. And then each is sampled through a high speed, each is sampled by a high speed commutator. So, if you could look at this, this will look as follows. So, this is the signal, correct. Okay. So, we have M1T, M2T, MNT, each is sampled by a high speed commutator. Okay. So, the commutator alternately samples the, so this is basically your commutator. Okay. which is alternately sampling. So, this commutator is alternately sampling M1T fine, and then these are multiplexed for transmission over the, these are multiplexed for transmission over the channel. Okay. And these signals are sampled to obtain a composite. So, alternately, so these signals, these are alternately, so the commutator alternately samples M1T, M2T, M2T, and here we have the samples are multiplexed. Okay. So, samples are multiplexed to form a samples are multiplexed to form a composite signal. Okay. And this composite signal is transmitted over the channel. So, composite signal is transmitted over the channel. So, the composite signal is transmitted over the channel. Okay. So, what are these? So, we have these signals which are low pass filtered. These are alternately sampled by the commutator, okay, as we have said, which is a high speed switching device. All right. Then the samples are multiplexed to form a composite signal. The composite signal is transmitted over the channel. Now, at the receiver, the samples from this the multiplex samples from this composite signal are again demultiplexed using a commutator, and again they are low pass filtered to yield the respective signals. Okay. So, this is transmitted over the channel. Now, at the receiver, the composite signal is demultiplexed. The composite signal is demultiplexed using another commutator. Demultiplexed using another commutator, followed by low pass filtering of the output signals. Okay. So, at the receiver we again have a commutator. Okay. We have a high speed switching device, which basically what it is doing is it is basically again demultiplexing. So, this commutator, so this is a commutator used for demultiplexing. At the receiver, which is used for demultiplexing, correct, and this demultiplex signals, correct, these are subsequently low pass filtered. For instance, this is low pass filtered, this yields your M1T, this is low pass filtered, this yields M2T, and this is also low pass filtered to yield M N T. Okay. So, these are low pass filtered, okay, and these are. So, this commutator, and this commutator is performing. So, you get the input from channel. Okay. So, you have the channel, so you get this from the channel. This commutator is then demultiplexing, okay, demultiplexes samples from the composite signal. Okay. And an important aspect, okay, so it demultiplexes the samples from the composite signal, followed by this bank of LPF low pass filters, right. So, each of these demultiplex stream of samples is individually low pass filtered to yield the appropriate signal. So, the samples corresponding to M1T are filtered to yield M1T, M2T, so on up to Mn T. And now it is important to note that these two commutators C1 and C, that is C transmitter at the transmitter, that is we call that commutator the transmitter as CT and commutator at the receiver as CR. These have to be synchronized, all right. Okay, so, these commutators, because the switching frequency, all right. So, we have to have CT, this is the commutator at the transmitter, and if we call this as CR, notice that CT and CR have to be both synchronized. CT and CR have to be synchronized. For example, okay, so this CT and CR have to be synchronized for, well, for error free operation, let us call it that way, because otherwise for error free operation, all right. If they are not synchronized, then what you reconstruct, the reconstructed signals will not be similar to the transmitted signals. Okay. So, let us take a simple example, a pictorial example of this time division multiplexing operation, all right. So, let us look at a simple example of this time division multiplexing operation. Okay. For instance, I have one signal that looks like this with samples so this is your M1T, okay, these are the samples, and let us say we have another signal M2T. Now, remember the sampling instants of M2T have to be between those of M1T, because we have a commutator which is sampling, let us say M1T followed by M2T and alternately repeating this procedure. So, we have the samples of M2T these are the samples of M2T. So, what we are going to have over here are basically, if you look at this, what we are going to have is we are going to have a sample of M1T, correct. We are going to have the first sample of M1T followed by the sample of M2T, correct. So, this will be followed by the sample of M2T, then we will have another sample of, well, M1T, followed by another sample of M2T, and this will proceed, so on and so forth. So, we have a time division multiplex operation, correct. So, these are samples of M1T, these are the samples of M2T, and this is your multiplexed composite signal. This is the multiplex composite signal, this is your time division multiplexing, this is the TDM signal basically, correct. This is the TDM signal, that is you are sampling, alternately sampling two signals and you are multiplexing them in the time domain by alternatively taking samples from each of the signals to be multiplexed, alright. And now you will also observe that if these sampling durations, now if you look at this, if this sampling duration is Ts, let us say both of them have equal sampling duration Ts, then in Ts if n signals are sampled, well, you have n samples per each Ts duration. Therefore, the duration between these samples of the composite signal is, well, Ts divided by n. In this case it is Ts divided by 2. So, the samples between the signal, correct. So, because in each sampling interval Ts you are sampling, you are generating n samples, right, one sample each from the sampled signal, the duration between the samples, correct, the duration between the samples in the time division multiplex signal is Ts by n, where n is the number of samples, alright. So, let us also note this. So, duration between samples is T, where T equals Ts by n. So, this is the duration between samples, n we have noted is the number of signals to be multiplexed. And Ts is the sampling duration, Ts is the sampling interval Ts is the sampling interval for each let us write this sampling interval for each individual signal or each of the constituent signals in the TDM signal, each of the constituent signals of the TDM signal. Okay, so, the sample, the spacing between the samples, consecutive samples of the TDM signal is Ts by n, where n is the total number of samples, alright. And time division multiplexing has wide applications. Time division multiplexing used in telephony, that is telephone communication systems, it is used in telemetry, it is used in data processing systems, alright. So, time division multiplexing has wide applicability because of its simplicity, right, it is simpler in comparison to for instance a frequency division multiplexing system, for instance even the cellular standards such as GSM, correct, right, the global system for mobile communication, which is the 2G wireless communication standard, also uses TDM, where the users of the different where the signals of the different users are multiplexed in the time domain, all right. So, TDM has widespread applicability, okay. So, TDM, which is time division multiplexing of the signals, this has wide applicability. This is used in telephony, okay. For instance, we will see later this is used in a T1 system where a large number of signals are multiplexed on a channel. This is used in telemetry, it is used in telemetry, it is used in, well, telemetry is basically where measurements are transmitted over a where measurements are transmitted over a communication system. This is used in data processing, this is also used, as we have said, in cellular communications, for instance GSM. For instance GSM, which is a 2D wireless standard. So, this has a large number of applications. So, TDM, time division multiplexing, has a lot of right, it is a key technology and has a lot of applications in a variety of communication systems, communication, data processing, right, data transmission, like telemetry, correct, telephony, landline telephony systems, correct, PSTN, public switch telephone networks, so on, and also cellular networks, that is your GSM, which is a 2D wireless communication. So, it has several applications, that is a very popular technology because of its lower implementation complexity, and which makes it well suited for application, which makes it well suited for widespread applicability in communication system, all right. So, we will stop here and continue with other aspects in the subsequent modules. Thank you very much.